Hello everyone, welcome back to Let's Unbound. Yes, we are going to solve FRQ 5 of AP Calculus PC 2025 exam. This is no calculated paper, so there is many must-know concept waiting for. Let's get started. Let y equal to f of x be the particular solution of the differential equation. Dy by dx is 3 minus x y square with the initial condition f of 1 is negative 1. And we need to solve 4th question. I will explain the 4 subparts when we do the problem exactly. So let's get started. Okay, find f double prime 1, the value of that mean value of d square y by dx square at the point 1 negative 1. Show the works that lead to your answer. Very simple. We have dy by dx. We need to differentiate. If you differentiate dy by dx, you will get d square y by dx. Then we need to plug it. Let's start. Dy by dx is 3 minus x times y square. Differentiate that. That is d by dx of dy by dx. Okay. I am differentiating with respect to x. There is one little problem. I have x also y. So treat this as two different functions. Y is a function of x. It can be sin x, cos x, anything made up of x. Right? So we need to be careful here. Okay. So now UV method. UV method, I hope you know. U, V, and you are differentiating this means u prime v plus v prime u. So my u is 3 minus x. My v is y square. What is u prime? Differentiate here u. 3 will become 0 when you differentiate. X will become 1, so negative 1. V prime is I'm differentiating with respect to x throughout. So 2y is a differentiation, and this y is a function of x. So again, you need to differentiate that y dy by dx. So it's very important. The chain rule in implicit differentiation. So let's go with u prime v plus v prime u. We got everything. So u prime is minus 1, v is y square, plus v prime is 2y dy by dx, u is 3 minus x. And we can simplify it further. Or we can, we need d square y by d square y by dx square at x, x is 1. Like the point is 1 comma negative 1. So wherever x comes, you can use that. So minus 1 is in the thing. Y square, y is minus 1, y square is 1. 2 times y is negative 1. Dy by dx at that one I need. Dy by dx at 1 comma negative 1, we need to find it. Okay, so now let me plug in. 3 minus x value is 1. Then this thing. That one an extra thing we need to do. Very simple. Dy by dx is given to x. So we can, given to us, we can use it here. Dy by dx at 1 comma negative 1 is 3 minus 1. Y square is minus 1 square, which is 2. That's it. 2 times 1, which is 2. So for this, you can replace with 2. Now solving, this is minus 1. This one is 2 times negative 1 times 2 times, this is 2. Correct. So everything will go 8 and minus 8. And finally, we got negative 9. Very simple thing. Very direct implicit and basic implicit differentiation is will be fine here. Now, part B. Write the second degree Taylor polynomial for f about x is equal to 1. Okay. So second degree polynomial means P2 of x we can name. How it will go about the point means. So f of 1. F of a you can say if it's x is equal to a. So here 1. So f of 1. That's it. Next one, f prime of 1 of x. F prime of 1, the x, this is given, times x minus 1 plus f prime of 1 by 2 factorial, that is 2, x minus 1 the whole square. So it will go f triple prime of 1 by 3 factorial, x minus 1 the whole. So actually there is a general term. How I write this? We have a general term for generating this Taylor series, which is f nth prime of a. This is your x is equal to a. N means the first term, no differentiation. 0. 0 differentiation means what? Just a function. N factorial x minus a whole power n. So if I need the third one, right? So this one is f of 1. You can use this from this, right? Or you can treat this as n minus 1 also. So 0, from 0 to 1, 0, 1, 2, you can plug in. So 0 means f of 1 by 0 factorial is 1 and 1 minus 1, which will be 0. So that is how it will go. F n prime of a by n factorial. So f of 1 will be f of 1. Then rest everything you can generate from this sequence. That is general term. And now you can simplify it. This is fine, but let's simplify it further. F of 1 is well defined in our main thing, minus 1. So we can use it. F of 1 is minus 1 plus f dash of 1, that is dy by dx at x is equal to 1. We already have this. Dy by dx is 2. So 2 times x minus 1. Then f double prime of 1, d square y by dx, also we find it, it's minus 9. So minus 9 over 2 x minus 1 the whole square. And you can further simplify, make look like a exact polynomial. That will be the best, I would say. So minus 1, 2x minus 2. Then minus 9 by 2, expand x minus 1 the whole square, x square minus 2x plus 1. And minus 1 plus 2x minus 2 minus 9 by 2 x square plus 9 by 2 and 2. Minus minus plus 9 by 2 times 2, it's just 9x minus 9 by 2. So let us write in decreasing order of powers. Minus 9 by 2 x square. These are like terms, they will go 11x. Then these are constant like terms. When you add them up, it's minus 15 over 2. Very simple addition, so I didn't explain that. This is a second degree Taylor polynomial. Right, that's part B. Now moving to part C. The second degree Taylor polynomial for f about x is equal to 1 is used to approximate f of 1.1, given that f third derivative of x is less than or equal to 60 for all x in the interval 1 to 1.1, including the endpoints. Use the Lagrange error bound to show that this approximation differs from f of 1.1 by at most 0.01. Okay, we need to find Lagrange error bound. So right. Okay, so here we go. R2 of x, we are going to use second degree polynomial we are using. So remainder error, R2 of x, remainder polynomial, it will be less than or equal to m by 3 factorial modulus x minus 1 the whole cube, because the Taylor polynomial is about x and m is the maximum. I will tell you what is m. So m is maximum of f of third derivative, the next derivative, third derivative on this interval 1, whatever the interval we are working on. Right, so the set bound like we made it. Now f third derivative is given to us. What they give? Modulus f third derivative of x is less than or equal to 60. So that means your m is 60. Correct? Can you connect it? So my m is 60. Now R2 of, we are working on 1.1 less than or equal to 60 by 3 factorial 6, 1.1 minus 1 the whole cube. What I need to prove is second degree polynomial, we are using that to approximate at 1.1. It should be less than or at most 0.0, means maximum is 0.01. So we need to prove less than or equal to 0.01. Let's see whether we get this. So this is equal to 10 times 1.1 times 1 is 0.1 whole cubed, right? So 10 times 0.01, okay, actually just 0.01, because 0.1 cube is, we can say 0.1 cube is 1 by 10 cube. So multiply by 10, you will get 1 by 10 square, which is, this is my way of explaining. So you can do, this is the answer. Yeah, I got this. Error bound using second degree polynomial is less than or equal to 0.01. This is what they have asked us to prove. So yeah, the approximation of f of 1.1 differs from f of 1.1 by at most 0.0. Right, and that's the proof part of C. Moving to last part of this question, D. Use Euler's method starting at x is equal to 1 with two steps of equal size to approximate f of 1.4. Show the work that leads to your answer. Okay, Euler's method, we did this in, yeah. Let's start. So you need to find del x, right? It is the step size. Okay, so two step size. So just the length of your interval we are working, b minus a divided by number of steps. So I need to approximate 1.4. I'm starting from 1. So 1.4 minus 1 by 2 steps. So 0.4 by 2 is 0.2. This is the one I will be adding. Now, next, after this is first step we need to do, find the del x. Next, the most important thing is I need to know first derivative because we will be using the slope at points. Dy by dx also called, you can write it as f dash of x. F dash of x is given to x 3 minus x y square, right? Now we are going to make Euler's table. X, y, x and y we know. M is a slope. How I will find it? Every time these will change. I will tell you how to find m. Then del x, we already found it. Then the new y or change in y. You know this formula, right? Y equal to mx plus c. It's very similar, but del y is m del x plus the old y. Okay, del y you can treat as new y, and just y is old y. Okay, now let me box it. Okay, now very simple. After this, we can just go ahead with substituting, simplifying, marking the numbers. Here we go. Okay, what is my x? You are starting at x is equal to 1. That should be 1. And let me fill up all the x values first. 1. Del x is 1.2. So next 0.2 actually. 1.2, 1.4. Once you got your 1.4, I'm stopping because we need f of 1.4. F of x means when at x is 1.4, you stop. We don't want to continue that much. So 2 steps with 3 values. At the second step, we'll get the answer. Now let's do solving part. Okay, here we go. What is y? When x is 1, what is your y? This is initial condition. We are f of 1 equal to negative 1. I hope you remember. Many questions we use this. So it's negative 1. How can I find this m? Finding m is dy, okay, actually f dash of xi. That's it. So xi and yi. Okay, both, it depends on both the variables, right? Very simple. If you're solving for this thing, plug in your f dash of x, the respective x and y values. That's it. So I will get 3 minus my x is 1, y square. Y is minus 1, squaring it. So 3 minus 1 time, which is 2. So this is my m. Now go for del x. Del x is fixed. It's 0.2. Right? So let me write it 0.2, 0.2. Now, everything I have, I'm going to complete new y. M del x 2 times del x is 0.2 plus y is minus 1, which is 0.4 minus 1, which is negative 0.6. Be careful with signs. Sign, okay? Now, this 0.6 will act as y, the next y, and we will continue the same process. Okay, plug in for m. Which is 3 minus 1.2 times 0.6 square is, what is 0.6 square? It's 0. Let me calculate it quick. 0.6 square will be 0.36. 0.36. And 3 minus 1.2 is nothing but 3 minus 1.2 is 2.8. No, 1.8. So 1.8 times 0.36. Again, just a normal multiplication and you will get approximately exactly 0.648. Okay. Now, do the same process. What is your m? 0.648 times what is your del x? Fixed at 0.2 plus what is your y? Negative 0.6. And do the process. You will get negative 0.4704. That's it. So now this will be our new y. and we don't want to continue further because z is f of x. So this is f of 1.4, correct? That's it. We approximated 1.4 using 2 steps. That's it. So this is your final answer. F of the approximated value of f of 1.4 is negative 0.4704. Very simple, but we need to be cautious with the decimals and signs here. That is where the most of the error will be there. Okay, that's simple. And thank you for learning with us. If you really like this and if you feel this really helpful to you, you can show your love by sharing, liking, and you can share your suggestions and feedback in the comment box. Also, if you want to join a student community of Let's Unbound, there is a link given in the description. You can use it to join a growing student community. Thank you so much again. Keep learning, keep practicing. We will be seeing on FRQ 6 video very soon. Until then, keep learning.